Okay, this is the Chapter 11, Part 1, the series test review. And as it says, if I can get that off there, for questions 1 through 3, it's just basically going to be a set of questions that ask you about convergence or divergence of a handful of series. So I just put a bunch of ones on here, similar to what you will encounter on the test. So I'm just going to go through each one of these and determine if they converge or diverge. So let's see if it will get my pens ready. This first one is, I think, again, a lot of these we can make a couple of different choices with. We do not have a calculator, so we have to do them by hand. So I think this first one, letter A, is integral test. So, and I'm just going to come over here. So integral of x to the 4th e to the negative x to the 5th. And we're going to integrate from the same limits that the series is, because basically the series is a Riemann sum, and so it's really just an estimate of what this integral would be anyhow. So I really think this is u substitution, where u is x to the 5th, and that means du is going to be 5x to the 4th dx. And just sort of pardon me for making this go a little bit faster and not taking up too much space. So we're going to have negative e to the u. The x to the 4th dx is just part of this integral, so I'm going to call this du over 5. And then I like to change my limits, although in this one it'll be really hard to notice that I do. 1 to the 5th is still 1, and infinity to the 5th is still infinity. So I think this integral, we have a 1/5 here, and then negative e to the negative u. And what I really just want to know here, I don't have to get down to the point where I know exactly what the number is, but I need to know if it is a number or if it is infinite. So I'm going to rewrite this as negative 1 over 5 e to the u, which would be then negative 1, oops, this is from 1 to infinity, 5 e to the negative infinity, no, positive infinity, I already changed that to a positive down there, and then 1 over 5 e to the 1. So this thing goes to 0 because e to the infinity is 0. So we have 0 plus 1 over 5e. So since this integral converges, I got a number out of it, that means this guy converges. Okay. So next one. So on this next one, I think we could technically do integral test. I think it's going to be a little difficult. I think it's some version of tan inverse, but because of the 9, I feel like that's going to make life a little bit hard. So I'm just going to compare this to 1 over n squared. And again, on a multiple choice, I hope that you will just look at this and say it acts like 1 over n squared, so converge. I'm going to go ahead and follow through with the proof and the actual test, and I'm going to do limit comparison. That one is my favorite. So we would compare our series to the one that we decided to compare it to, and really it should be divided by 1 over n squared. I'm going to go ahead and multiply it by that, because I know now I have 7n squared over n squared, which is 7, which means that these two things should act the same. That's what it means if we get a number, and since this one converges by p series, we know that the other one does as well. Sorry, my handwriting is a little sloppy on this. Okay, so similar thing on letter C. I'm going to compare this to 1 over n cubed, which converges by p series. And again, we would really want to prove that using a limit. So we would do this 8 over n cubed minus n. And again, technically divided by 1 over n cubed, which multiplies. And this one is 8. Again, I think you should make this decision about converging right about at this point, but on a free response, if we wanted to prove it, we would have to do the limit. Really similar on D. I'm going to compare it to 1 over n, which diverges by p series. Again, this is the point where I would say diverge here. If I needed to prove, it would be limit as n approaches infinity of that n squared 1 divided by 1 over n, which is the same as multiplied. So we're going to get an n cubed plus a 9n here. I'll go ahead and write that one out since I have some space here. N cubed plus 9n over n cubed, which is 1. Again, as long as we get a number here, we know that they both act the same. And then letter E, I see based on the -1 to the something that this is an alternating series. I would really like this to be, I guess it doesn't really matter. In my brain, I really want it to say that, but it probably doesn't really matter in this case. If it was a P series, I would definitely want to make sure I understand that. So I take the limit of the non-alternating part. If the limit of the non-alternating part is 0, then we have converge, which is definitely true in this case. So this one converges as well. Okay, let's see if we can scroll to the next group. So on letter F, again, alternating. In fact, F, G, H, and I are all alternating. So I'm going to take the limit as n approaches infinity of the non-alternating part of all of them. And I'm wondering if that is 0 on each case. So this one, 2n minus 9 over n plus 10. I'm wondering if that's 0. This one, that root n over 1 plus 9 root n, is that equal to 0? And then finally, limit as n approaches infinity of 2 to the n minus 1. That one's a big mess. Oops. Okay, is that equal to 0? Okay, I might have to do a little bit more work on that one. Okay, so back at F, remember with NN FEPL, that logarithms grow the slowest, so this is bottom heavy, so this is sort of a big check. Yes, that means this one converges. This one, the limit is actually 2, so no, it's not equal to 0, which means this diverges technically by nth term test. On this one, again, it's not equal to 0, it's equal to 1/9. Look at the ratio of the root n's, so this one diverges by nth term test. This last one, what I would want to perhaps look at is rewriting this a little bit. So the n plus 1 squared on the bottom, that can stay. The 5 to the n, I'm going to write as 5 to the n times 5 maybe. And then this 2 to the n, and then I guess the 2 to the -1 goes down here. I'm going to bleed over here into this problem. I'm going to rewrite it one more time because this 2 over 5 to the n, they're both to the n, so I'm going to leave them there in the numerator. And then I have n plus 1 squared here. So since the top of this, although exponential, when it approaches infinity, because this number is less than 0 or less than 1 on the inside, it will head towards 0. So this is going to head towards 0 while the bottom heads towards infinity. So that is going to be 0. So yes, this one converges. Okay, and then Word got a little bit excited. And so I had to restart on this problem. So I would, on this one, again, it is a P series, I would like to rewrite the denominator here as n to the 1/4, which means the P value is a 4th. And in the P series test, if P is less than or equal to 1, we have something that diverges. So that one's divergent. And then on to the last row. So K and L are really similar. They are both going to simplify down into geometric series, but we got to write them that way first. So on this one, the 7, since it's to the -n, is really going to go down in the denominator, so 7 to the n. And then I'm going to call 6 to the n plus 1 6 times 6 to the n. I sort of have the 1 here and then the plus n. And the reason I like to do it that way is because now I see 6 is really the a, and 6/7 is the r, and then to the n. So absolute value of r is 6/7, which is less than 1, so this thing converges. And then similar to this one, except for it's going to be in reverse. So maybe we can sort of skip ahead a little bit. That's going to be 7 times 7 to the n, because I didn't skip too much. So in this case, 7 is the A, 7, 6 is R, absolute value of which is 7, 6, which is greater than 1. So this one diverges. Greater than or equal to 1 on that one. Okay, on M, it looks like we would want to do some sort of comparison to 1 over n squared, which converges by p-series. And again, I prefer to do the limit. If we had to prove it again at this point, even without the limit, I'm going to say this converges because I'm pretty confident that we have created something that grows the same. So I'm just going to distribute that in so I can sort of see when I do this limit I get 2 because it's 2n squared over n squared. So again, since I get a number here, I know they both act the same. Letter N is an alternating series, so I just need to do limit as n approaches infinity of the non-alternating part, and if it is 0, I get converge, and it is, so this one converges. And then finally on O, I'm going to compare again to 1 over n, which again at this point I would say diverge, because this diverges by p-series. And again, to prove it, I would want to do perhaps the limit. Again, you can do direct as well, but I just prefer this one when I can get away with it. So again, I divide by 1 over n, in this case, flip and multiply. So I get 1/3, which is a number, which means they both should act the same.